Okay, this is very hard.
Very hard.
Cannot do
Just
this.
pick someone who's never gone up there.
Yeah, pick an. Oh, he's got a pen.
Can I use the one, my favorite one?
Sure. But I want you to explain it as well. Or do you want to draw it and have someone explain it?
Yeah.
Okay. We're going to have more of these. We're going to spend most of our time doing this today, okay? Okay, I call this your space, okay? So, this space is yours. I don't know why I did that.
Yeah.
That's really weird.
Y'all never heard of MySpace, so.
No, they're a Facebook generation. And Twitter. I have Twitter. Hang on a sec.
What are you doing? What are you doing?
You have to explain it while you're drawing it. I'm sorry. So
Okay.
erase the -1.
What are you doing?
Okay.
Actually, let me do this. Rebecca, you can go ahead and sit down. I want you to explain how you got to this point. Can you do that? You can't. Can someone get to this point
took
for
it
me?
off
Yes, I can. I can.
I know you can.
Get off the board and I just.
Wait, what?
Let's get Rachel.
Okay. Rocky.
Rachel.
Okay. You'll stand up here. You're next. Okay. You can get to this point.
Yeah.
Can you explain to the class?
Maybe.
Okay. Do what I do, but I'm over there. Okay.
Okay. C has the 4 valence electrons.
Just kidding.
And then O has 6. And you do that. So then it's. I don't like this one.
Thank you, Christina. Okay.
And then do that one.
Why are you doing
Why?
that? Yeah.
Why are you doing it?
Oh, to make another bond because C is not happy.
Why is he not happy?
Because he doesn't have the same amount as O.
What amount is that?
A tenth.
Okay, so how many?
Right now we have, right here it's just O alone.
It
No,
wants
it's
a
not.
full
It's
shelf, so
eight.
it needs
Right.
8.
Oh, but O alone
Yes, senor.
has 6.
It actually has 8.
Shared it.
Oxygen valence electron alone has 6.
Yeah, that's what I'm saying.
But now it's bonded right now. So now how many valence has 8?
So
You're right. She's got this.
She got it down.
She's got it down.
she just needs to talk, though.
Owning
And then
this.
you do that again.
Are we gonna do the rest for homework?
Because it's got.
homework.
We're gonna do this together.
Can't do math in my head.
It's okay.
If we're not stable, will it explode?
Oh wait.
No, senor. It'll just break up. Mwahaha.
Just break.
Mwahaha. I love that evil laugh at the end.
Yes.
Okay. So, all right. So, the point being is, thank you, Rocky. Can you guys give her a hand? It's hard to stand up here and explain it. That's big props, and you're next. So, but let me explain this. She started off with the number of valence electrons for each atom. They're not bonded yet. This one has 4. This one has 6. She took one set of electrons as a bond because one line is 2 electrons. One dot. I'm sorry, 2 electrons is 1 electron. Okay. And so what happens here is you have 2 electrons here. 2, 4, 6, 8. Oxygen is happy, but she says carbon is not happy because it has 2 and 4. So what she did was, well, oxygen was willing to, well, I have 8. I can share 2 electrons with you. So this set of electrons moved over here, creating a double bond. And so now carbon has 2, so 1 and 2, 4, 6. So now it has 6 electrons, but it's still not happy. Carbon is a drama queen. You have to understand that. So you have 2. So oxygen gives 2 more electrons, and bonding with this carbon, it's deciding to take 2 more electrons to share with carbon. Now oxygen has 2 lone electrons with 3 bonds, each bond being 2 electrons each. So now oxygen has 1, 2, 4, 6, 8. What about carbon? 1, 2 has 2 lone electrons. 4, 6, 8. Are we all happy or what?
Yeah.
Okay, are we good?
Yeah.
This is okay. So that's how I got the molecule. Okay, carbon monoxide. So taking all this away, we said now that they're bonded, they now have a formal charge because they're bonded now. Carbon's no longer plus minus 4 anymore.
Or just do the
Okay, so what's the
opposite.
charge? So, no, not the opposite. And you're up.
You are not in your space.
If it's the opposite, wouldn't it be like that?
Am I trying to find the charge for carbon or
You can do
Oxygen.
carbon.
Would you like to do carbon too?
I'll do oxygen.
I'd rather do oxygen.
You can start with oxygen. Doesn't matter what you start with. You can start with oxygen or carbon. Doesn't matter.
Okay, so you wrote this.
Yes, I did.
Now we have to use the formula, right? For that.
Okay. Yes, this formula.
I don't really know what to call it.
I call it formal charge. What do you call it?
Okay, that's what I'm gonna call it.
Okay.
Call it the formal charge formula, which is valence electrons minus lone electrons minus 1/2 times the bonded electrons. So since we're solving for oxygen, it's number 8 on the periodic table, so it has 6 valence electrons and then 2 lone electrons, so we subtract 2 minus 1/2 the bonded electrons, 2, 4, 6, 1/2 of 6, and then you just simplify it. So oxygen formal charge is +1.
Yes, on the oxygen side. Not the oxygen alone, but this is now +1 charge on the bond. But yeah, you're right. Okay. Okay. Does anyone want to try carbon?